Today we're going to implement some simple platforming mechanics, moving and jumping. Here I have my example scene. Over here on the left you can see that I have parallax background. I have some tiles, which are just this block, and I have this character right here. The hero is a kinematic body 2D, and you might notice that I've made all the sprites children of the collider. This is because at some point I'm going to want to flip the entire scene, and Godot does not react well when you try to flip a kinematic body 2D. It's much easier to flip the collider and have everything else attached to the collider. Returning to the example room here, you can see that I have a camera 2D attached to the hero, and I also have this controller. So let's go into the controller and see how I've set this up. Basically, if you press left and not right, the character moves left. If you press right and not left, the character moves right, and if neither of these is the case, the character just doesn't move at all. And then if you press the X key, the character jumps. Now these are just the controls. They don't actually do anything yet. If we go into the hero's script, you can see it's pretty empty right now. I've set up some constants that will be useful when it's implemented, but the character doesn't actually jump or move. So let's fix that now. The easy way to control a kinematic body 2D is to set a velocity and then use the move and slide function. First, let's define movement. The input to the move function is a vector 2, but we actually only care about the x component of that vector. If we go back to the controller that I set up, you can see that it's either vector2.left, in which case the x component is -1, or vector2.right, in which case the x component is 1. When we call the move function, we're going to set the velocity to be the x component of the direction that's passed in. Then, in order for that to do anything, we need to add a line in physics that moves and slides according to the velocity. The reason that we're assigning this value to velocity is because if you attempt to move into a wall, the move and slide will return that the new velocity is 0, and we need to update the velocity with that new value. Okay, so we're moving, but it's extremely slowly, and that is because we forgot to add one important thing, which is that the velocity is not just the direction, we also need to multiply it by the movement speed. Okay, so now we're moving around. But, as you can see, the character is not obeying gravity, so let's add that into the physics. To add gravity, we basically need to consider two different situations. One is when the character is in the air, and the other is when the character is on the floor. Fortunately, Godot has a very simple method in kinematic body 2D objects for determining this, which is called isOnFloor. So, if isOnFloor, we don't need to do anything for now. But if it's not on the floor, we want to fall. So in order to fall, we're going to make use of gravity. So velocity dot y. We're going to increase the velocity because the down direction is the positive direction on the y-axis. Plus equals gravity multiplied by delta, where delta is the amount of time that's passed in the current physics frame. And as you can see, now the character obeys gravity. Great. Looking at the character, it's a little awkward that it faces in the same direction whichever way we go, so let's have it flip horizontally when we travel the other way. So going back to the move function, we want to flip the collider, which, remember, has all of the sprite assets as children of it. Basically, we want the x component of the scale of the collider to match the direction. So if the character is facing right, then the x component of the scale should be 1, and if it's facing left, then it should be -1. This is pretty simple. All we have to do is say body collider dot scale dot x equals direction dot x. So as you can see, this works, but we do have something weird happening where when we stop moving, the character disappears. To understand why this is, let's go back to the controller. In the event that no key is being pressed, the actor is moving with vector2.0, which means the direction for movement will be vector2.0, and therefore the scale will be 0. With a scale of 0, the collider and all the sprites attached to it will disappear. The easy fix for this is that we only change the scale of direction.x is not 0. And that fixes that problem. Next, we want to implement jumping. All we have to do is set the character's y velocity to their jump speed. But of course, we only want to do this if the character's on the floor. I mean, you could have some sort of double jump system where you can jump in the air, but we're not going to be doing that for now. So if is on floor, then velocity dot y equals negative jump speed. And of course, it's negative because the negative direction is up. So trying this out, I'm pressing the jump button, but nothing's happening. Let's go figure out why this is. Let's take a look at the move and slide function. It has several arguments. We've only provided one of them. And if you look at up direction is the up direction used to determine what is a wall and what is a floor or ceiling. If set to the default value of vector 2.0, everything is considered a wall. Okay, so if we go back to our code, we did not set an up direction, which means that it is currently considering everything to be a wall. In order to jump, we have to be on the floor. We can say that gravity works, but gravity occurs when we're not on the floor, which is clearly the case here. So, if we want it to recognize the floor, we need to set an up direction for move and slide. Let's say vector 2.up. Okay, we are now able to jump around. There is one more thing to consider, however. Right now, we have our jump speed set at 500, and in a platformer, your jump height is going to be extremely important. So we may want to adjust how high the character can jump. But the issue is, it is somewhat unclear what number of jump speed translates to what character jump height. For example, let's suppose in this room, we want to add a platform up here. Now, the question is, can the character jump up to that or not? We don't know. We'll have to test it out. So yes, the character can, but we might not want them to be able to. Maybe this is supposed to be just out of reach and they have to find a different way to get up here. Rather than just changing the jump speed and using trial and error to figure out the right value, it would be much better if we could just say exactly how high the character can jump. Fortunately, we can do exactly that. Let's define a function called getJumpSpeed. So this is going to compute how high we want the character to jump. In this scene, one block is 32 units high. So let's say we want the character to be able to jump 2.5 blocks up. So that would put them right in the middle of this platform and they would not be able to jump on top of it. So we'll define max jump height as 32 times 2.5. The formula to determine the maximum height of a parabolic trajectory given the initial velocity is h, the height, equals initial velocity squared divided by 2 times the acceleration due to gravity. If we rearrange this a bit, we get that the initial velocity is equal to the square root of 2gh. So this gives us square root of 2 times gravity times max jump height. So in velocity, we're going to replace this with get jump speed, and then we no longer need our jump speed constant. All right, as you can see, the character now only comes up to here and is unable to jump onto the platform. And that's how you can set up simple platformer mechanics with a configurable maximum jump height. Thanks for watching.